Okay, this is the clicker review that we did in class on ionic bonding, and I'm going to give you a walkthrough, and hopefully if you were struggling with any of it, this will clarify. So, first question, positive ions are called, and those are called cations. Negative ions are called anions. So this is all of our negatives, this is all of our positives. Next question, what is the charge on the iron 2 ion? Okay, so this is really simple. The rule is that if we have an element located in D block, a transition metal, which is everything in this section, also tin and lead, even though they're not in this section, the rule applies to them also, they can form more than one charge. Since they can form more than one charge, we use a Roman numeral when we name them, and the Roman numeral tells us what the charge is. So if it's an iron 2 ion, that means its charge is a +2. If it was, let's say, a lead Roman numeral 4 ion, then that would tell us that it would have a +4. They will always form cations. You will not see negative charges on any of these because they're metals. And also remember that any other element in the table, at least for the purposes of our class, if it's in column 1, it's always going to form a +1. If it's in column 2, it's always going to form a +2. These form a +3. I told you these get an X, although there's your tin and your lead. They are those exceptions. So these typically share. Then it was -3, -2, -1. Those are the charges they get because they want to be like a noble gas. So that's why we use those Roman numerals, because these can have +1, +2, or +3, in some cases even more. All right, the next question, what is the correct name for NaOH? So this is a memorization question. For ionic compounds, we name the first thing, which is always going to be a metal, or I guess the one exception in class we used was this polyatomic, ammonium, could also be there. So sodium. And then this was a polyatomic, and you were supposed to memorize polyatomics. So that is hydroxide. So we just name the first thing, sodium, name the polyatomic, hydroxide, and we're done. Quick rundown of polyatomics for you, the ones that you are supposed to have memorized. Ammonium was the only positive one. And the only other one that did not contain, that did not end in ate or ite, was this one, the OH, which we just did, which was hydroxide. All the other ones that you had to memorize for class contained either ate or ite. So how do we remember those? Well, one thing you can remember is that ate always has one more oxygen than ite. So if you memorize phosphate, that's PO4 with a -3 charge. That means phosphate is going to be PO3 with the same charge. And we're going to see the same thing with nitrate, which is NO3 negative. Nitrite will be NO2 negative. Sulfate, which is SO4 -2. And sulfite is going to be SO3 -2. So if you memorize the eights, then you'll know the ites. We also had carbonate. And we didn't learn a carbonite. I don't know that there is one. Carbonate was CO3 with a -2. And then there was hydrogen carbonate, which actually has another name. It's called bicarbonate. I know some people put that on the quiz, but hydrogen carbonate, which is H in front of the carbonate, and the charge is -1 on that. And then the last one you had to learn was the one that included chlorate. So chlorate was ClO3, chlorite was ClO2, and then that one actually went even lower. There was a hypochlorite, which was ClO, and then there was also per, as in hyperchlorate, which was ClO4. So this was perchlorate, chlorate, chlorite, and hypochlorite. So those were the polyatomics that you had to know. Obviously there are a lot of other ones, you saw them on the list, but those you should know for the test. All right, next one. What is the proper name for Cu2SO43? Okay, So what I told you guys to do was we're going to start with naming the first thing, and this is a polyatomic, so we're going to name the second thing. We're now going to go back and see, is this in D block? Because if it is, we're going to need a Roman numeral, and copper is. So what we need to figure out is what the Roman numeral is going to be, and the Roman numeral represents what the charge was on the copper. So probably the easiest way to do this is actually write this down. Our formula consists of 2 coppers and 3 sulfates. Now we know that ionic compounds are always neutral. Therefore, we know that if we can figure out what the negative charge is, we'll know what the positive charge must be. So sulfate is one of the ones you're supposed to remember. Sulfate has a -2 charge. And there are 3 of them in this formula, so our total charge coming from sulfates is a -6. That means that our positive charge has to be +6 so that they'll cancel. Now, how many coppers did it take to get that charge? It took 2. That means each individual copper must have had a +3 to get the +6, and so this would be copper 3 sulfate. So just to do one more example of this, let's say you had iron, Fe. Let's say you had Fe3PO4 2. So we would know this is iron phosphate, but we need a Roman numeral because it's in D block. So again, we can do what I did here. If you're unsure, let's say we have 3 irons, it says. And on this side, we had 2 phosphates. So we had PO4, PO4. And we know, or you're supposed to know, that phosphate always has a -3. So our total charge of negatives this time is -6. That means our total positive charge has to be +6. So 3 irons times what gives us 6? 2. If each of these is a +2, we would get 6. So this would have to be iron 2 phosphate, because that would be the charge on each individual iron in the formula. All right, next, how many dots should be in the structure for oxygen? Okay, so this is where you should remember for your periodic table this. 1, 2, 3, 4, 5, 6, 7, and 8, with the exception of helium. That's how many valence electrons they have before they form ions. So oxygen happens to be over here. It has 6. So we would do this. 1, 2, 3, 4, and then 5, 6. You can do it that way. You could also do 1, 2, 3, 4, 5, 6. It doesn't really matter. The one thing you could not do would be this. 1, 2, 3, 4, 5, 6. That would be wrong because we're going to represent these being by themselves when we draw the formula. Okay, so that is how you would do any of those, and you would not be given these and asked to do dots because, again, they can vary. What charge do halogens acquire when they form ionic bonds? When they form ions is really what it should say, and halogens are your group right here by the noble gases, and they all form a -1. Again, the other thing that you should always remember about your periodic table for the purposes of this test, -3, -2, -1. Here's your D block, +1. These all form a +2, a +3, X, -3, -2, -1, X. And that's your halogens, this column right here. Next, the maximum number of electrons an atom will usually gain or lose, typically 3. It is true you can get a couple of 4s, like 10-4, lead-4. In fact, I've seen chromium-6. But for purposes of what typically happens, you're usually going to see no more than 3 gained or 3 lost when they form ions. Next, which is not true about ionic compounds. Okay, this is just memorization. All ionic compounds are solids. All ionic compounds are brittle, and they all have high melting points, and they have orderly 3D patterns, meaning they're like sort of like crystals. They have, just a regular repeating shape. And the lowest whole number ratio of that regular repeating shape that is called your, they form, I think they actually call this a crystal lattice, but that is called a formula unit. That is the lowest ratio of your ionic compound. They are not called molecules. Molecule, technically, it refers to covalent compounds. Covalent compounds form molecules. Ionic compounds form formula units, because you don't see an ionic compound as a gas floating around like you do molecules. You always see it at room temperature as a crystal, and you would just figure out what the lowest ratio is in that crystal. Ionic compounds dissolved in water conduct electricity. The other time they'll conduct electricity is when they're molten or melted. They do form aqueous solutions. That literally means dissolved in water. They're not called precipitates. A precipitate's what you call a solid that forms in a reaction. So they would not be called, if they're dissolved, they couldn't be a precipitate. So A and B would be your answer. Ionic compounds are always neutral. True. That's the whole reason why we have to do crisscrossing to get their formula. Cation should be written on the right. That is false. The cation always goes on the left. Polyatomic should be treated as a single unit. That is true. Like, for example, when you're doing aluminum and you're doing, let's say, carbonate, you always, when you crisscross, you don't change these numbers. You would put it in parentheses. You would do Al2, CO3, parentheses, 3. You would not multiply this out or change this in any way. You just put parentheses around the whole thing. We're pretending like it's a single unit. The proper name for Cl negative is going to be chloride ion. We always change the ending on an anion to ide. If it's a polyatomic, you don't change the end. So perchlorate is actually ClO4, and chlorate is ClO3. But a chlorine by itself that's neutral would just be Cl. Chloride is the negative ion it forms, and this is incorrect because we only use the Roman numerals for those transition metals. Next, when potassium reacts with phosphate, what will be the correct formula? So potassium's in the first column, that means it gets a +1. Phosphate's a polyatomic you're supposed to memorize, and it's a -3. Crisscross your charges, you get K3, PO4, which would be D. And the last question, the correct formula for iron 3 chloride. So iron 3 means our iron has a +3. And chloride always has a -1 from the periodic table. When we crisscross that, we're going to get this one, FeCl3. So hopefully that is a helpful tutorial as far as the review we did in class. And honestly, if you know this review well, you should do very well on the test. The questions are not the same, but they are similar. If you know how to write a formula from a name, write a name from a formula, the properties of ionic compounds, and how to do electron dots, you should not have a problem on this test.